Hi everyone, this is Lucy Kim from the Peer Tutoring Club. In today's video, we're going to learn about definition of monomial, multiplying polynomials, variables with exponents, how to multiply and divide them, and using exponents in algebra. Now let's see definition of monomial. Definition of monomial is a polynomial with just one term. For example, 3x squared can be a monomial. Now we're going to learn about how to multiply polynomials. A polynomial looks like this: 4xy squared plus 3x minus 5. As you can see here, this one has three terms. To multiply two polynomials, we need to multiply each term in one polynomial by each term in the other polynomial. And we need to add those answers together and simplify if needed. Let's look at the simple cases first. To multiply one term by another term, first multiply the constants, then multiply each variable together and combine the result like this. So as you can see here, 2xy multiplied by 4y equals 2 times 4 times xy times y. So 2 times 4 is 8, and xy times y equals xy squared, so it's 8xy squared. To multiply the single term by each of the two terms, we can solve it like this. So as you can see here, if we say to multiply 2x times x plus 3xy, then we firstly need to multiply 2x times 2 and then plus 2x times 3xy, which is 2x squared plus 6x squared y. Then how can we multiply binomial times binomial? Each of the two terms in the first binomial is multiplied by each of the two terms in the second binomial. So if we need to multiply a plus b by c plus d, then we need to multiply a term called FOIL. So it stands for first, outers, inners, and lasts. So first are AC, outers are AD, inners are BC, and lasts are BD. So as you can see here, when we say to multiply 2x plus 3 by xz minus a, then when we use FOIL, we can easily solve it as 2x squared z minus 2xa plus 3xz minus 3a. When we say to multiply two terms by three terms, then FOIL won't work here because there are more terms now. But just remember, multiply each term in the first polynomial by each term in the second polynomial. So as you can see here, when we say to multiply x plus 2y by 3x minus 4y plus 5, then we need to multiply x by 3x, which will be 3x squared, and we need to multiply x by negative 4y, which would be negative 4xy, and then we need to multiply x by 5, which would be 5x, and then we should multiply 2y by 3x, which would be 6xy, and then we need to multiply 2y by negative 4y, which would be negative 8y squared, and then we need to multiply 2y by 5, which would be 10y. So the answer should be 3x squared plus 2xy plus 5x minus 8y squared plus 10y. So these were multiplying polynomials. Now let's move on to variables with exponents. A variable is a symbol for a number we don't know yet. So it is usually a letter like x or y. An exponent, such as the 2 in x squared, says how many times to use the variable in a multiplication. For example, when we say y squared, then it's same as y times y. So let's see what are the exponents of 1 and 0. When the exponent is 1, we just have the variable itself. We usually don't write the 1, but it sometimes helps to remember that x is also x power of 1. Then what about exponent of 0? When the exponent is 0, we're not multiplying by anything and the answer is just 1. For example, y power of 0 is 1. Multiplying variables with exponents. So how do we multiply this? Y squared times y cubed. We know that y squared equals y times y, and y cubed equals y times y times y. So let us write out all the multiplies. So y squared times y cubed equals y times y times y times y times y. As you can realize in the result, that is 5 y's multiplied together, so the new exponent must be 5. So the simple way you can memorize is that multiplication is same as adding the exponents. How about dividing? When we say to divide, then in a different way with multiplication, you need to subtract the number below by the number above. So for example, when we say y cubed over y squared, then the answer will be y over y. So these were the simple way of multiplication and division in variables with exponents. Now let's move on to using exponents in algebra. So the exponent n in a power of n says how many times to use a in a multiplication. For example, when we say 5 cubed, then we simply say that 5 cubed is 5 times 5 times 5, which is 125. Now let's learn negative exponents. So a power of minus n equals 1 over a power of n. Also, by changing the signs of the exponents, we get a positive exponent. A power of n is equal to 1 over a power of negative n, 1 divided by the negative exponent. So we can move an expression between the top and bottom of a fraction when we also change the sign of the exponent. So for example, x power of negative 1 equals 1 over x, a simple reciprocal. In other example, 5 power of negative 3 equals 1 over 5 cubed, which is 1 over 125, which is 0.008. When we combine positive and negative together, here's an example with positive and negative exponents. So the problem is 4 cubed times 2 power of negative 5, 9 power of negative 1, and 3 squared. We can put the values with negative exponents at the bottom. We must need to remember to make the exponents positive. So 4 cubed times 3 cubed over 2 power of 5 times 9. Let's simplify it. So 3 squared is 9, so it is 4 cubed times 9 over 2 power of 5 times 9. The 9's cancel out, so it's 4 cubed over 2 power of 5. Because 4 cubed is 4 times 4 times 4, which is 64, and 2 power of 5 is 2 times 2 times 2 times 2 times 2, so it's 32. So 64 over 32 can be simplified into 2. And this was an example for using exponents in algebra. So it's all for today. Thank you for watching and see you next time. Bye!